All right, let's dive into a massive topic. How in the world do we secure artificial intelligence? As this tech gets smarter and more integrated into our lives, how do we build the guardrails to make sure we can actually trust it? Let's get right into it. This quote right here really nails the problem. We're in a situation where the technology is absolutely sprinting ahead, while the rules, the regulations, the safety nets, they're kind of still lacing up their shoes back at the starting line. And that huge gap between what we can do and what we should do, that's what we're going to explore. It helps to think about other big tech shifts. Remember when everyone was moving to the cloud? That felt like a huge deal, but the risks were, relatively straightforward. AI, though, that is a whole different ballgame. We're not just talking about where your data lives anymore. We're talking about deep ethical questions, major privacy concerns, and the very real possibility that an AI could just make things up. The stakes are just so much higher.
So if we're going to figure out how to secure AI, we first have to get on the same page about what we're even talking about. Because AI isn't just one single thing. It's this whole spectrum of different capabilities, and each one comes with its own unique set of challenges. First up, we've got artificial narrow intelligence, or ANI. And honestly, this is the AI you already know. It's your phone's digital assistant, it's the facial recognition that unlocks your screen, it's the complex system inside a self-driving car. These things are incredibly powerful, but they're specialists. They're one-trick ponies, designed to be amazing at a single job.
The next step up the ladder is artificial general intelligence, AGI. Now this is what researchers are really aiming for. This is the AI that could learn, reason, and problem solve across any field, just like a person can. We're not there yet, not by a long shot, but an AI with that kind of general-purpose intelligence would be a complete game changer.
And finally, way out on the horizon, there's the theoretical endgame, artificial superintelligence, or ASI. This is the stuff of science fiction, for now. A future AI that wouldn't just match human intelligence, but would blow past it in ways we can barely even imagine. And thinking about that really drives home why it is so critical to get the foundations of security right now. Okay, so when you're facing this huge spectrum of AI, from what we have today to what might be coming tomorrow, how do you even begin to secure it? Well, the answer isn't to try and become an expert in everything all at once. The real solution is to have a solid, dependable framework, a kind of roadmap to guide your strategy.
So here's that roadmap. A truly secure AI strategy is built on these 5 core pillars. Now, we're not going to try to boil the ocean today. We're going to zero in on 3 of the most critical ones: managing the AI's lifecycle, putting in really strict data controls, and making sure our approach is always human-centric. Let's break those down. Let's kick things off with the AI lifecycle. This is the entire journey an AI system takes, from an idea on a whiteboard to a fully operational tool. And embedding security into every single step of this process, well, it's completely non-negotiable.
Look, security can't just be a checkbox you tick off at the very end. It has to be this continuous thread that's woven through every single phase you see here, from the second you start planning and collecting data, all the way through to deployment and beyond. If you wait until the end to think about security, you've already lost.
And within that lifecycle, you need some critical checkpoints. One of the coolest is something called AI red teaming. Think of it like hiring a team of ethical hackers for your AI. Their entire job is to try and break your system, to find all the vulnerabilities before the bad guys do. And you pair that with constant checks for bias and fairness, all documented in a serious risk mitigation plan.
Now let's talk about that second pillar, data. You have to understand data is the absolute lifeblood of AI. It's the food, the fuel, the air it breathes. It's everything. And that is precisely what makes it AI's single biggest vulnerability.
And one of the most dangerous threats to that data has a pretty scary and, well, accurate name: data poisoning.
So what is it? Okay, imagine you're teaching an AI to recognize pictures of cats. You're feeding it millions of images. Data poisoning is like an attacker secretly sneaking into your library and slipping in thousands of pictures of dogs, but labeling all of them cat. What happens? The AI learns the wrong lesson from the very start. The model itself becomes corrupted, and all of its future decisions will be built on that fundamentally flawed foundation.
So how do we defend against something like that? It really starts with the fundamentals. Things like super strict access controls. We use what's called the principle of least privilege, which is just a fancy way of saying people and systems only get the keys to the data they absolutely need to do their job, and not one byte more. You add in systems to detect weird activity, and, this is crucial, you keep the data used for training completely separate from your live production data. It's like building a firewall against contamination.
And that brings us to our third pillar, where we're going to shift gears from the purely technical stuff to the human side of things. Because AI doesn't just exist on a server somewhere, its decisions impact real people, and we have to think about the real harm they can cause.
You see, AI-related harm isn't just one thing. It happens on multiple levels. For an individual, it could be getting denied a loan because of a biased algorithm. For an organization, it could be a PR catastrophe from a flawed product. And at a systemic level, it can have huge societal impacts that affect every single one of us.
This all boils down to a fundamental problem of trust. So many of the most powerful AI models operate as what we call black boxes. We can see the data that goes in and we can see the answer that comes out, but the decision-making process in the middle is so incredibly complex that it's basically a mystery, which leads to a really important question. How can we possibly trust a decision if the system itself can't explain how it got there?
A huge part of the answer is a concept called human in the loop, or HITL. And for any high-stakes decision, this should be non-negotiable. It means that no matter how brilliant the AI is, there is always a human expert in place to review, to validate, and, if necessary, to override its output. You get the incredible speed of the machine, but you combine it with the wisdom and judgment of a person.
So, how do we tie all these different ideas together? The life cycle, the data, the human element, it all comes down to a single, powerful philosophy for the future of AI security: zero trust.
That philosophy is zero trust. Now, in traditional cybersecurity, zero trust means never trust, always verify. For AI, we're applying that same logic. We never ever automatically assume an AI's decision is correct. Instead, every single output has to be verified against three key ideas. Is the AI actually able to do this task? Does the data used have integrity? And is the action benevolent? In other words, does it align with our goal of not causing harm?
So let's just quickly recap the big takeaways here. Securing AI isn't about buying one magic tool. It's a whole strategy. First, you've got to weave security into the AI's entire lifecycle from the very beginning. Second, you have to protect that data pipeline with everything you've got. And third, and this might be the most important one, you have to design systems that always prioritize and empower a human to have the final say.
And all of this leaves us with one final, pretty challenging thought. As these black box systems get more and more powerful, we're going to keep running into this problem. If a decision, no matter how accurate it seems, can't actually be explained, can we ever really truly trust it? That's the question we're all going to have to answer. Thanks for watching.